This is a warning from the future. In 200s, galaxies will begin to collide and crush into one another. Stars will explode and entire cosmic clusters will merge as the universe begins to collapse. All because the very force that's pushing our universe apart is weakening. Here's the science behind the end of the universe. Scientists have discovered that almost 70% of our universe is made of something we can't see, hear, or feel. It's an invisible force known as dark energy. Since the Big Bang, this mysterious power has been pushing the universe apart. But what if dark energy isn't constant? What if it's changing? And what if it gets weaker? To understand what could happen when dark energy fails, we must first understand how it works. Dark energy was first proposed to explain why galaxies are moving apart at faster and faster rates. Normally, gravity should slow them down, but something was causing the expansion of the universe to speed up. Scientists theorized that dark energy was a property of space itself, a sort of repulsive force that counteracts gravity. Imagine placing two galaxies far apart. They're initially attracted to each other because of their mutual gravitational pull. As time goes on, they move closer and closer together, sir. Now imagine that space itself between those galaxies pushes them apart. That's the effect of dark energy. But how do we measure something we can't see? Well, by studying distant galaxies, scientists can observe how much they're affected by this repulsive force. By understanding the relationship between distance and speed, they can calculate the amount of dark energy present. But recent studies suggest that this relationship may not be as straightforward as previously thought. It's like watching a car at the bottom of a hill. If we only observe it briefly, it appears to be stationary. But over time, we see it roll downhill. In the same way, scientists believe the expansion of the universe may be speeding up because of dark energy. But if we look at a small portion of the universe, it might seem like nothing's happening. So the key to solving this mystery lies in studying distant galaxies and understanding how they drift apart. If the rate at which galaxies recede is slower than expected, it could be evidence that dark energy is weakening. And here's where things get scary. If dark energy continues to decrease, the expansion of the universe will slow down. Eventually, the force of gravity will overcome the repulsive force of dark energy, and that's when the big crunch occurs. Galaxies will literally begin to fall back together. Stars will explode as they collide. Entire cosmic clusters will merge, and the universe as we know it will collapse. Eventually, all matter will be crushed together in a single, infinitely dense point. This may sound like a far-off threat, but the truth is, the big crunch could happen sooner than you think. Some scientists estimate that if dark energy is weakening, the universe could collapse in as little as 100 billion years. That's just a fraction of the 100 trillion years it took for the universe to expand to its current size. But it's important to remember that time isn't just a tick-tock on the cosmic clock. Time itself is woven into the fabric of space-time. And if dark energy is weakening, that means time, as we understand it, may not be constant either. It could be changing in ways we never imagined. The implications are truly mind-boggling. Everything we know about physics, about the fundamental laws that govern the universe, could be rewritten. The story of existence, the rise of stars, the birth of planets, even the emergence of life itself, may be altered in ways we can't yet comprehend. Dark energy is not just a scientific curiosity. It's a fundamental aspect of existence. It shapes the very fabric of reality. So here's to the unknown, to the mysteries that lie beyond our current understanding. And here's to the relentless human spirit of exploration and discovery. We may not be able to predict the future, but we can choose to be its architects. So let us marvel at the vastness of the cosmos, the complexity of the universe and our place within it. Let us embrace the unknown and push the boundaries of human knowledge.